If you pick up a tiny stone from the beach and toss it into the ocean, it sinks instantly. It's heavy, it's dense, and gravity pulls it straight to the bottom. But right now, all over the world, there are massive floating cities, cargo ships carrying thousands of metal containers, cruise ships weighing over 200,000 tons, constructed almost entirely of heavy, thick steel. If a tiny pebble sinks to the bottom of the ocean, how on earth does a skyscraper made of steel manage to float beautifully on top of it? Welcome to Simple Things Surprising Histories. Today, we are unraveling the invisible physics and the fascinating history behind one of humanity's greatest magic tricks: why giant steel ships don't sink. For thousands of years, humans built ships out of wood. And it made perfect sense. If you throw a log into a river, it bobs on the surface. Wood floats naturally. But in the 19th century, the Industrial Revolution changed everything. Engineers wanted to build bigger, faster, and stronger ships powered by steam. To do that, they needed to use iron and steel. When the first iron ship designs were proposed, the public, and even many experienced sailors, thought the engineers had lost their minds. They said, "Wood floats, iron sinks. It is common sense." But a visionary engineer named Isambard Kingdom Brunel knew something the public didn't. In 1843, he launched the SS Great Britain, a massive passenger ship made entirely of iron. The crowds watched in suspense, expecting it to plunge like a stone. Instead, it sat perfectly on the water. Brunel wasn't defying physics, he was just using a rule discovered 2,000 years earlier. To understand why Brunel's iron ship floated, we have to travel back to ancient Greece to a brilliant mathematician named Archimedes. Legend has it that Archimedes was stepping into a bath when he noticed the water level rising. He realized that his body was pushing the water out of the way. This is a concept called displacement. Archimedes discovered a fundamental law of nature. When an object is placed in water, the water fights back. It pushes upward against the object. The strength of that upward push is exactly equal to the weight of the water that was pushed out of the way. This upward push is called buoyancy. If the object weighs more than the water it pushes away, it sinks, like our tiny pebble. But if the object weighs less than the water it pushes away, the water holds it up. It floats. But wait, steel is heavy. A solid block of steel will absolutely sink. So how does a steel ship displace enough water to float? The secret lies in its shape and a magical, invisible ingredient: air. A ship is not a solid block of metal, it's a carefully designed shell. The hull of a ship is essentially a giant steel bowl, and the inside of that bowl is filled with cabins, corridors, engines, and mostly empty space, air. In physics, floating is all about average density. Steel is much denser than water, but air is incredibly light. When you combine the heavy steel shell with the massive volume of light air trapped inside it, the average density of the entire ship becomes less than the density of the water. Because the ship is shaped wide and deep, it pushes a colossal amount of water out of the way. And remember Archimedes, that massive volume of displaced water pushes back with a massive amount of upward force. This elegant trick of physics allows us to build ships of unbelievable size. But there is a limit. If you put too much cargo onto a ship, it becomes heavier. It sinks deeper into the water to displace more weight. If it sinks too deep, water will spill over the top, fill the empty air spaces, increase the density, and the ship will go down. To prevent this, in the 1870s, a British politician named Samuel Plimsoll introduced a lifesaver. He mandated that a circle with a line through it be painted on the side of every cargo ship. This is the Plimsoll line. It's a simple, brilliant visual marker. As long as the water doesn't rise above that line, the ship's average density is safe, and the physics of buoyancy will keep it afloat. So, the next time you see a colossal steel ship gliding effortlessly across the sea, remember, it's not defying gravity. It's a perfect, beautiful balance of shape, trapped air, and the relentless upward push of the ocean. If you enjoyed discovering the hidden physics of the world with us today, please hit that like button, share this video, and subscribe to Simple Things Surprising Histories for more stories hiding in plain sight. Thanks for watching, and stay curious.